Still the first slide. Okay. So yeah, what we're going to do in terms of practical setup is we're going to use this virtual Slurm cluster. The nice thing is there's a login node. Slurm is fully configured, but the worker nodes will only start running, will be powered on. VM will be powered on when jobs appear. So at first, if you start a job or an interactive session, there's a bit of a delay before it starts running, unless somebody 2 minutes before you already had a job running and that got powered down. EESSI is there natively. It's fully configured. You don't have to install EESSI. Actually, you can't because we won't give you sudo rights on this. You're a normal user, so you get that experience as well for once. And EESSI is only available on the worker nodes, not on the login node. So if you log in, you'll first have to start an interactive job, and only then you'll have EESSI to play with. Some people here already have access to this cluster, I think. Who already has access to this cluster in the cloud? It's the same one from the hackathon. So I think Frank and Dan and some people already have. If you want to play with it, all we need is your GitHub account, if you have a GitHub account. If not, an SSH pub key is all we need. So if you give us your GitHub account, we'll do this. So we'll go to your account and we'll basically go to the .keys URL. Let me give this a bit bigger, and this gives you the pub key that's connected to your GitHub account. Many people don't know this, but that's a very easy way. So all we need is your GitHub handle. We have a pub key, and we can give you access to the cluster. If you don't have a GitHub account, that's fine. You don't have to create one. Just give us an SSH pub key, email it to me, and we'll create you an account and drop that pub key in there. All right. So once you have the account, you'll have to use SSH to log in. In this case, I'll assume example as your GitHub handle, and you'll show this. It's a fixed IP. We don't have a fancy host name or DNS or anything like this. So you just SSH into the IP. Now let me show you. Is this actually going to work from here? Oh, that's a good question. Probably not. Yeah, okay, fine. I'll just use the slide. I can give you the interactive experience after. So you just SSH with the terminal into the cluster. You should see a nice fancy welcome message like this with a big black box that we never actually filled in. If you want to get some more details on this cluster in the cloud setup, so what kind of worker nodes are available there, how do you submit a job, how do you start an interactive session, you can find it there in the hackathon repository as well of our EESSI GitHub organization. So we've used this setup a couple of times during hackathons that we did end of last year and early this year. Once you have access to the login node, you can clone our EESSI-demo repository. Now all we have there is some examples. Let me show you that as well in here. EESSI-demo. That's maybe a bit too big. So if you clone it, you'll get a directory like this that has subfolders for a couple of applications that we have installed already in the proof of concept EESSI repository. Bioconductor, GROMACS, OpenFOAM, TensorFlow. These are basically just example job scripts. If you go into a directory, you'll find always a run script. That's the main job script, let's say. In this case, we're going to run it interactively. And the run script is usually pretty simple. It just loads a module. So it assumes the module is there. And it is thanks to EESSI. And then it does some magic. In this case, runs a Python script. And the idea is that you can very easily see, once you have your job script and your code already prepared, how easily it is to start running if the software is just sitting there waiting to be used. So you get to be a scientist today, and as long as you pick one of these four or five software packages. Then after you did the clone, you have the EESSI-demo ready. You can start an interactive Slurm job. So this eventually will get you an interactive shell on a worker node. It can take a bit of time before that shell comes back because Cluster in the Cloud will automatically boot a VM for you for that specific node type. When you're submitting the Slurm job, you'll have to specify a shape as well. And the shape basically corresponds to the different instance types that are available in AWS and that we have registered in the cluster. This one in particular, that's a C6G, so G is for Graviton, that's an ARM instance, a Graviton 2 instance, I think, and 2x large determines the number of cores. So in this case, you'll get 8 cores, I think. So you should basically just run an srun command like this. Number of cores, that doesn't really matter. The shape is an important one, so if you want to play around on an ARM node, you can just copy paste this one, or you could change the shape to something else. If you run the list node command, it will tell you which shapes are available on the cluster. And then either directly, if you're lucky, or after a minute or 2 or 3, you'll get a shell like this, which tells you you're on that specific type of worker node. So then we have a shell on a node where EESSI is available, and then it's very easy. So you can check that we indeed have EESSI mounted. So in /cvmfs, you will find our pilot repository. You should see this as subdirectories essentially. Ignore the first one. That's a temporary thing we still have there, but at some point that's going to disappear because we moved those directories into the versions directory. Host injections is something special that Alan will explain when he's talking about how we can support CUDA and GPUs. So that's a way of basically injecting stuff into the EESSI software stack. It could be something related to GPUs, something related to compilers, something to MPI. So bring your own MPI library, plug that in, and use that one rather than the one that we provide. And the latest is just a symlink. That's let's say the currently recommended version of EESSI to use. If you just do an ls/cvmfs, you may not see anything at all, because unless you directly specify the full repository, it may not be there. So it needs to get auto-mounted, so you have to talk to it first before you can actually see it. So don't be surprised if /cvmfs is still empty. You really have to type the first command. So that's just checking that things are there. It should be there. And to really set up your environment, you can source our init script. So using the latest symlink, you just source the init bash script that will do the detection of your CPU. So am I using an ARM? Am I using an Intel Haswell? Am I using an AMD ROM? It will tell you in the output what it detected. It will set up your environment to use that part of the EESSI software stack, and then you're basically good to go. So if you're using the C6G shape, you should be seeing output like this. So it detected an ARM CPU, and it's a Graviton 2. And it's going to use that part of the EESSI software stack. And then you're good to go. All the scientific applications that we have included are there. You can check with module avail. What is there? You'll see GROMACS, OpenFOAM, TensorFlow, and a whole bunch of dependencies, including, I think, 2 versions of GCC that we have installed in there. So you can try and figure that out. And then you can go to one of the subdirectories and run the run script, check what's in there, run it, and see that the application is actually starting and doing what it's supposed to be doing. Also here, when you first run a software package on a worker node, you'll have a cold cache, a cold CVMFS cache. So what CVMFS will do is, as soon as you try to use a certain software package and all the files that you are triggering, all the files that you need to read to be able to use that software, CVMFS will pull those in the background automatically. It will download them to the local cache on the node, and this may take a couple of seconds, if you're very unlucky, minutes, but usually it's quite quick. So you may see, like, you may go, come on, react, and then eventually it will just fire up. If you try the same run command again, it will be almost instant, because then it's essentially local. Yeah, and that's about it, the same bunch of links again. Now let me actually switch laptop so I can show you this interactively as well. So don't need this. So the people who don't have an account on the cluster yet, you'll need me for that. But let me do the quick demo first. Make it a little bit bigger. Okay. So I mentioned I have 100,000 tabs open here, but I do have the slides here somewhere, so I can just copy paste from this. Okay, so step 1. You SSH to the IP, you use your GitHub handle once you have the account, and it will give you this as an answer. Great. Then step 2, clone the EESSI-demo, but I think I already have it here. Yep. So that's done. Start an interactive job. I'll just copy paste this. Let me check. I guess some people are already playing. Yeah, there's 2 nodes already running, and they're actually idle. So if I cheat a bit and just use a shape that's already running, I'm using a C6GD. That's for SSD as drive, I guess. I get a shell pretty quickly. In here, I can check. It looks like there's nothing there, but you have to use the full path to trigger the auto mount. So now it's auto mounting. It will show us the contents of the EESSI repository. That looks great. Latest is a symlink in 2 versions, the 2021.12 version. So we'll just use that. Latest init bash. That's the script we need to source. Like this. This will tell us, ignore the warning, that's something we have to fix. This will tell us we're running on an ARM system, a Graviton 2. So I'm going to use that part of the EESSI software tree, the software stack. And you see here there's a very long path, the version, the software layer. So there's a directory on the same level for the compat layer. We're running on Linux. We're running on an ARM CPU. We're running on a Graviton 2 ARM CPU. And in there you have the modules that correspond to this software stack. So it does all these detections for you. LMOD is included in the compat layer itself, so you don't actually need LMOD on the system at all. But once you've set up your environment, you can check what's there. This will be a long, scary list. So lots of software there, lots of dependencies, of course. OpenFOAM is there, TensorFlow is there. You can easily find them. Okay, so that's all working. I've sourced the script, did the detection, and now I can actually go in and do my science. For example, run the TensorFlow script, which just loads the module and fires up a Python script. You can see this is like, come on, let's go. So CVMFS is downloading all the files in the background for you. Which may take a couple of minutes, especially with Python software, because it needs to download all these tiny files, right? So it's the same as on an NFS file system, so it takes a while, but you see it just starts and tada, science is done without ever installing TensorFlow or anything else. So, yeah. No. So then TensorFlow is also downloading the actual data set. Yes, that's possible. Yeah. So we don't only blame. Ah, you mean for the hang? You mean? Yeah. Okay. No. For this delay, you're stating that the run is taking time because of EESSI, and it isn't. It's actually TensorFlow downloading the actual data set that's being. Yeah, that's true. So to actually test the hang, I should just do something like this. TensorFlow. Now, of course.
Well, the Python is quick.
No, I don't have the module loaded. Right. It was only loading it in the script. So if I do it like this, now of course now it's going to be quick because the cache is warmed up. So this should be quick. It's still Python and TensorFlow, so it's still not. But yeah, you can see the same thing if you do OpenFOAM. So here this doesn't download anything, or does it? No, because it's a tutorial case that's included with the software itself. And here you see the same, come on, let's go, and eventually it just goes and does. And CVMFS only downloads the actual files that are needed. So it's not like it's downloading the whole software directory. It's only the files in the software directory that's actually needed. The binary you're hitting, the libraries that are needed for that binary, the files that are needed for running the tutorial, and so on. I'm not sure if OK was the right idea, but yeah. So please try and get that experience yourself, because I think it's very difficult to do in an easier job than this. If this is not enough to get a scientist working in the cloud and on the cluster and on the laptop with the same software environment, then it's game over, I guess. I don't know. Okay. So the GitHub key thing again. Well, all I need is your GitHub handle. So what I'll do is I'll fire up this management account. This is just a root account essentially to manage things, and then if I can remember how I add people, yeah, like this. So I just need your GitHub account, your name, and then I can add you to it, and then you use the IP in the slide, and you can straight in log in and start playing. So, sorry? You can shout it to me, or you can give it in Slack. Yeah. Sorry, you sent me a mail. Okay, that works.
Wait. You want all this on the
You okay? So you give me. It's a pub key.
your email is on PubKey.
No, my inbox is not. There's nothing special. Okay. So, did you go with Gwen? Is that okay? Gwen. Oh, Gwen. Last name. Alpha Whiskey Echo. Like this. Okay. And I'll use my GitHub account here. It's just going to use my pub key, but then I can, I think, do this and add the pub. Yeah. So now the SSH should be working for you. Anyone else? Yeah. Let me walk around so I don't actually have to do this on the stream. I guess.
Yeah, but let's switch off the stream. You can point the stream. I mean, the Zoom we can leave on. Stream.
Yeah. So the YouTube. So if people want to do this, if they want to get access to the cluster in the cloud, you can find us on Slack. Post your GitHub handle there. We're happy to give you access to play around with EESSI. So this is all with sponsored credits from AWS, and eventually we'll set up an Azure equivalent of this as well.